Hey, Andy.
What's up, dude?
Not much. Are you ready to learn?
I am ready. I'm really curious to see. I'm really curious to see Richard's pipeline in action.
Right.
Are you actually gonna like clean some or reduce and align some files today?
So today, actually, it's gonna be introduction to Python. So,
oh, just that.
Yeah, some people asked me like, why do we import? Why do we do like very simple things? So I want to go over the very basics, and then at the end of the day, I'm planning for like an hour. At the end of the day, I should be able to go over like the first function of the call pipeline, so everybody can know exactly what each line is doing.
Okay.
And then have everybody go through all the functions afterwards by themselves.
Nice.
Yeah, so it should be pretty familiar. How are you setting up at your new place?
Good. It's been really good. It's been really nice.
Hey.
What's up?
What's up? Ready to learn?
Hi. Martel, you were asking me about the catalog cross-matching. Have you looked into that any further?
Well, I haven't actually, I don't actually know where to start. That's the problem. I look at Cal, but I don't know how to interpret what I'm supposed to be doing with it, or how to import it, or call functions, or what functions I can even use.
I see. How far or how much do you know about Python?
I know a little. I know enough to see what's going on, but I can't do anything advanced.
Okay.
Yeah, that's why I'm having trouble. I don't really know a whole lot.
That's perfect. I designed the class to begin with the very basics, just calculations. Then we'll go over variables, what objects are within Python. By the end of the class, we should be able to read the call pipeline, so we can know exactly what each function is doing. I'm gonna just wait a little bit longer, see who else is joining. Here's, oh, Katrina. Hey, Katrina. Making myself some coffee. Okay, so we can go ahead and begin. It's 5 past 1:30. Katrina, Victor, how much do you know about Python?
Not much. Yeah, I know the basics. I'll be honest. I've started lots of intro courses, and I never really. I just yeah. I've started the intro. I know the foundation of it, but I haven't really started practicing too much.
That is perfect because I designed this to be very, very introductory. I based off of Python's official documentation. It's official tutorial, so I can send that link over to you guys. But the cool thing about this is that if you have any questions, of course, you can stop me at any time and ask me, or I can explain further. So let me share my screen. Great. Okay. Can everybody see my screen and hear me well?
Yeah.
Yes.
Yes.
Perfect. Okay. So first, we're going to start with using Python as a calculator. So the most basic, as basic as you can get. First, I'm going to open up what is I've installed Python, IPython 3, which is just a Python interpreter in order to have an interactive version of Python running. The way that it works is at read, evaluate, print loop. What it means is that it's going to read some value, evaluate once I hit enter, and then it prints out its value, which is 3. So if I want to do something like 3 plus 5, it gives me 8. I can also do subtraction. I can multiply using an asterisk, and division. Now, once you divide using the forward slash, it's going to spit out a what's known as a float. That's a decimal point inside the number. So now we've gone over 2 different objects, which are integers, just the number, and floats, which are having a floating point somewhere inside of the number string. Also, if you write just a point at the end, that's going to convert it to a float with a 0 at the end. You can also raise numbers to a power by putting 2 stars, 2 asterisks. And can anybody tell me what's going to happen if I do this, what the result should be? Oh, we haven't gone over that yet.
9.
Somebody said negative 9. So it's gonna read the power first because it takes precedence over the negative. And what you can do always is enclose it in took a screenshot. There we go. 3 raised to the 7th power. Now, you can also do floor division, which is just giving you, you can use, for example, 17, floor divided by 5. That's going to divide it, well, 5 goes into 17 3 times, just 3, and gets rid of the remainder. Now, if you want to only get the remainder, you can do 17 percentage 5. That's just going to give you 2. 5 goes into 17 3 times, and then there's 2. Now, we can jump into assigning values to variables. To assign a value, you can first define a variable that's going to be any string numbers and letters. To find a better stamp on the camera. Any string of numbers and letters, it has to begin with a letter, can be uppercase, lowercase. For example, it's fine. The total amount of money you will pay for a coffee. Say adding taxes. So tax is going to be equal to 0.0825. Now let's define a value of 1 coffee to be, say, $4. And then let's define another variable called total. That can just be coffee plus value for coffee times taxes you pay for it. Oh, okay. So now total, you write total, and Python gives you back the value for that variable. That's 4.33. Another thing you can define to give value to a variable is a string. So say you have, you're going to write a sentence. So you have a subject equals my name, and whenever you write a string, you want to enclose it either with double quotation marks or single quotation marks. And you'll see when to use each in a little bit. So say Alex, now verb, you can define that as box. There you go. And now we can do sentence. Subject plus verb. That's going to give us a concatenation of the two strings. But there's a problem here. Once we write sentence, it's going to be all together. So what you can do is combine your variables that are already defined and add in between just another value. For example, here I have a string with an empty space. Now, sentence has a space in between. Any questions so far? Let me go over why you would change between double and single quotation marks. Say you want to write food, the contraction. So Python is reading the first and the last, well, first and the second single quotation marks, and whatever's in between, that's defining as a string. Whatever's outside of it, it's not going to recognize, and then it raises a syntax error. So what we can do is either change quotation marks for the whole string to double quotation marks, that works. Or you can also do, if you are adamant about using single quotation marks, is use a backslash behind that quotation mark, and that kind of escapes it. There we go, that works as well. Now, there are functions already built into Python. One that you will use quite a bit with scripts is going to be length. So you can do length copy, for example. Ooh, okay, sorry. Okay, yes. So the length of a string is going to give you back the number of characters that string contains. Oh, one more thing I should mention is if you have something defined as an integer and a string, you will get a type error. You cannot add an integer. Anyway.
Can I say something?
Go ahead.
If you're unsure what a certain object is, you can use the type function and it'll tell you. So if you do type open parentheses and then like coffee, it'll tell you that it's an integer. You can do it for subject, and that's really helpful because sometimes you just don't know like what specifically an object is, and so this is just a really useful function for that.
True. Thank you for adding that in. Oh, Wendy is joining. So, yeah. Hey, Wendy, we're going over variables in Python. So defining variables, the way you do that, you write a variable using either an uppercase or lowercase letter, followed by either numbers or letters, then equal sign, and whatever you want that the variable to be. In this case, we have assigned strings, and we've also worked with assigning integers and floats. Okay. Now, let's see. Oh, you can also any string is indexed such that if you have our sentence is that you do sentence and then add brackets at the end, and then you can give it an index. For example, if you give it a 0, it's going to be the very first character. So there's 0 index. If you do 2 is going to give us the third letter, E. And we can also do negative numbers to get the trailing characters. If we do -1, we get the last character in our string. And indices are also important for lists. We would use that a lot too, and I'll get to that in a moment. You can also use slice. For example, if I only want to get the last word, which is dogs, I can do -5 colon -1. That's going to give me the last few characters, but I can also just leave it empty and have the colon. It's going to give me from -5 to the end. That's pretty much good. Okay, so now we can go into lists. Let's say that I want to find a list. We do that, you close it in brackets, and a list is a comma-separated list of objects. So you can have, for example, 1, 2, 3. That's a list with three indices, and it's only made out of integers. Of course, I can also have different types of objects. For example, a string, 4. You can mix and match inside, and you can always do the index of the list. For example, 0, it will be 1. You do the last item of the list, the string 4. You can get the length of your list as well, 4. And a list can be nested. So you can have, to find another list, it's like the of strings. So now, to find another list, it's going to be enclosing the two lists. So now, the length of x is 2. If we print x, that gives us a 2-dimensional list. And of course, we can get x1 to just get the second item, which is list A. Now, building up on those built-in functions, pretty cool built-in function for lists is append. You will use that a lot as well. So you can have L.append. The way you use a function of a list, in this case, it's a method of the list object. The way you run those is dot, then the function name, and then parentheses. For this function, it takes one argument, which is whatever you want to append at the very end of the list. So I can have 5. Now L has been mutated to have a 5 at the end. Let's see. One other function pertaining to lists is pop. What pop does is it pops out the last item of the list. So now L has been moved at that 5. You can also do, let's see, add it back in. You can also give pop an argument, which is, it's an optional argument, which is the index that you want to pop out. In this case, let's say that I want to pop out the string 4. Now the list is made out of just integers. Any questions so far about methods?
Can I say something again?
Please.
So if you're like curious what kind of methods of an object has, I think from here you can just do like L dot and then either press tab or enter, and it should show you all the functions that that object has. Yeah, there you go. So if you're ever curious about what your object can do, you can do this, and then you can see and then go look about what they do or whatever. But so this is all of the methods that this list object has, and this is how to see them.
Thank you.
And that's for the IPython thing, right?
Yeah. Oh, Andres, what's up?
Hey.
So yeah, let me try. Actually, you can do.
Yeah. So that's only, that's only in IPython. You can't do that like in a script or whatever. It's just gonna break.
Right. And you do.
Yeah, but any IDE should have something like that.
Yeah. Any IDE is
yeah.
gonna have. Yeah. Exactly. Unless you're hardcore and just do it in a text document.
Savage.
Okay, so if you're using Ubuntu, you can follow along, by the way. I know a lot of you have Jupyter Notebook or Anaconda. You can use that as well. Here I'm running, I can run just Python 3, the pure interpreter. Let me try that here. I can find this, and then, yeah. It gives me the list of them, of the functions, but it doesn't let me like scroll through them. I want to write it out. Anyway. Okay. So far so good. We can also do another fun one that you can use, insert. And for insert, it takes two values. The index where you want to put your value, and the actual values. So you want to insert 9, place number 1. Also 9 here. You can also l.sort. It's gonna give sort it from the lesser value to the greater value. 1 to 9. You can also use sum of a list. Now sum, just like length and type, is the open function of Python itself. It gives you this, just a number, but it doesn't mutate L, which is it is. Another function that you will use a lot, and I should have started with this, is print. You know the famous hello world. The difference here is that it doesn't give me an out. So it's not just Python reading value and spitting out whatever the value is stored, but it's actually just giving a user-friendly, readable text to you. And you see the difference there. Once we go into scripting, when you write your own scripts and you run them, some things are going to be printed if you tell it to print them, but some are just going to be run in the background, and it's not going to do this every time. Now, with print, you can also enter a list of values. It doesn't have to be the same type of object. So you can have, for example, number 3 in my list. Print 3, space, and list. The space is added once you add a comma. That space is automatic. You can also do, so if you add \n, that's another enter for a new line, or if you press enter for writing. So you can write something like all word and no, double on. And close your string. That gives you a nice list of words. Now, okay, so if we only give Python a list to say whatever's inside of our print function, if we just give it that 3, L, it interprets it as a tuple. A tuple is a list of items that are enclosed in brackets. I mean, in parentheses. Sorry. So we can have 2 equals 3 L. You don't use them as much as lists. You can just touch over them. They're immutable. So with list, you could define this one equals 0. Now the second item of the list is 0. You do that with tuple. This 1. Type error, tuple does not support item assignment. So yeah. So we can jump into statements in Python. Couple of statements can be written just like regular English, not like that. For example, 1 in L. In is a statement in Python, and this whole thing, 1 in L, is a test for Python. It's going to check if the value 1, exists in the list L. It's going to spit out true. Now, true, with a capital P, that's a Boolean object. We do type 1 in L. Boom. if we do one not in L, it's a beautiful Python. So simple. One not in Python, one not in L. It's also Boolean, of course, but the value of it is false. We do example. We find a mocha. It's also $4. Copy. We can do double equals to check, test Python to see the value of one variable is the same as another variable. So copy equals mocha, question mark, true. You can also do exclamation mark equals, that means does not equal. So copy does not equal mocha, false, very equal. One more thing you can do to change the value of an item is plus equals, especially if it's, I believe only if it's a integer or a float value. You do mocha plus equals 1, mocha equals 5. Of course, copy not equal mocha, true. Let's see here. Oh, there's also one in, let's say, not in L. You can also add or. What or does is it allows you to do two different tests on the same line, and if one of them is true, the whole block will be true. So say 1 in 8. No, it's false because there's not. And of course, true because one of them is true. We just do 1 in 8 false. So one of the items needs to be true. Now, if we have and so two tests, 1 in L, 1 in A, both have to be true for the end block to be true. In this case, now false. We had not in A. Both statements are true, so the whole block is true. You will use that mostly in loops. So we'll jump into loops now. First one that we're going to look over is while. So, for example, so y equal to 0. While y is less than 10, less than is also a test, either to be true or false. So right now it's going to be true, first time ever, right? We can write, for example, print y, print the value of y, and then set it so that it increments y by 1. Now, this simple loop at the first iteration will check this will be true. It will print 0, and then it will add 1 to 0. So now y will be equal to 1. And then it's going to iterate over. And go back to the first line and check this. It's still going to be less than 10. It's going to do the same thing over and over until it reaches 10. It's going to print y at a value of 9. That's 1, makes it 10. And now 10 is not less than 10. So this breaks right there. Print it. It goes from 0 to 9. And now the value of y is 10. So that's when it goes. A more practical loop would be you can write two different variables on the same line, just separated by a comma, have an equal sign, and then have the value separated by commas as well. Yeah. A equals 0 and B equals 1. We can have while. Let's set a limit to the printing. Let's write Fibonacci numbers from, let's say, 0 to 100. So, well, A, Fibonacci number index is less than 100. We're going to print the value of A. And then we're going to have A be equal to B, which is the next number. We have B equal to A plus B. Last two digits. Enter here. I get the first Fibonacci sequence numbers from 0 to 100, not inclusive. One important thing to note that I forgot to mention is that anything inside of the loop needs to be indented. Here, IPython does the indentation for me. We're used to using 4 spaces or a tab. to do an annotation block. And then if you write anything outside of the indent, it's going to do it after the loop. In this case, A is already greater than 100, so it just didn't compute the loop. It just printed. Oh. Now, let's see here. Let's see. Any questions so far? Any comments as well? You can also do, and you use append inside of while loops quite a bit. For example, to increase the number of a list, let's say while L is less than 40, L dot append, you're gonna append the value 0, just add it with zeros. Oh, length. Okay, sorry. The length of our list is less than 40. We're gonna append zeros to the end. So now L, just a list of zeros, with the original values at the beginning, and it will print the length of our list. That's 40. That's what it's like. We're gonna go over if statements. The way they work is they test whatever you give it, whether it be true or false, and it runs the value inside if it's true. If it's false, it's gonna just skip, and it's gonna do it once, unlike the while loop, which iterates several times. So you can have if A in find A again. If A in A, if that's true, then A dot append B. If that was true, A dot append B again. Cool, what you can do is if B, so if B is not in A, then append it. Of course, since it's already there, append it. That's that. So we just define it again, and we append it to the method. Let's see here. Something that you can do if A in A fits there, say print A found. Another statement you can use is else if, which stands for else if. So it checks for the first test. If it fails, it's going to try and run the second test. But if it's true, it's not going to do the else if. It's just going to break the whole chain of if statements. So else if B in A. B found. And we can just do else at the end. That means if these two are false, then it's just going to run the very last statement. And else, we just write else colon. And they will be found. So we can run this. A was found. We can do A, Bob, the very first index. We can run our loop again. So if B was found. We can pop the very first index again. And A or B were not found because A is not composed of C and B. Questions? Okay. The last loop that we're going to go over is for loop. For this, I'm going to do a very practical example. Let's read my list of observations from July 31st. Let's read the header data for all of those frames. So what we're going to use is import glove. Glove is a package that I installed, or I think it comes installed with Python built in already. What gloves let you do is write Unix commands inside of Python. You'll see what I mean by that in a moment. Import is a statement that lets you use other scripts inside of your own script. Let's import glove. Let's import. Okay, so you can also do, you can import a single function from a package that you have installed. So you can do from, we're going to use the package fits, the function fits from the package astrofy.io. So now we're going to define first our list of fits files. I'm going to use glove.glove. This means we're using the method glove of the glove package, of the glove module. I'm going to give it a string, which is going to be the path to our items. So in this case, I'm going to do home documents, CTML data, name 2007, and then I'm going to write the beginning of my list of align, rate, solve, and reduce items. If I hit tab, that means I made a mistake somewhere. I think it's into. I'm going to try the one from the lights. 31st, lights, A-WCS. I'm going to select the first one. So example. Okay, so if I do this, it's only going to make a list of one item, which is just the first fits file. What I can do here is replace this, the numbers, with an asterisk. That's going to make a list of all the documents that begin with A, WC is reduced, and M with fit. So if you hit enter, let me show you list of fits. That's my list of all the items. And they're not sorted by number. What I can do is just sort list of fits. And that's not the way you use sort. The way you use sort is sort. There we go. Now we print it, and we have great. I'll sort it out. Now, the way that you read the header data, you can do. You can choose. You can Google this astrofy.io. Usually the first link gives you the official documentation. Go here, fits the timing, you give it file path, and here's a whole tutorial on how to read fits files. But the steps that you take. Okay. What you do here is you define a header data unit object. It's going to be a list. So header data unit list will be fits that open. You're going to use the open method of the fits class. And now we do list of fits. And to show you an example, I'm going to do the very first item only. And now I can define header with 0 item equals my HDUL dot header. to be the very first item. And all these steps, of course, are in the documentation as well. But if we type in just header, that spits out the header, all the header information for the first bit file in my list. So you can see this information such as the filter that was used and filtered, the light frame, the date observed. So for this example, we're going to do a list of all the observation dates and times. I'm going to read date observed. For that, we can do letter 0, and then just type in the string where you found that information. So that would be date-obs, enter, and there's the information that you need from that text file. So let's do a for loop. It's going to iterate through all of the files and populate a list of dates and times. So first we create a list, an empty list, dates. That's going to be appended to. Now we can do for I. This is the way we write a for loop. For I in list of dates. For every item in that list, I'm going to do the same thing. So HDUL, header unit list equals bits that open that item. We use I for by convention, but we can use any variable that you want. Header is going to be equal to my header unit list, the zero item of it, that header. And then the date time, we'll find this variable to be header date OBS. Now date time is going to be that date that we want. We can just do dates that time and date time. Then we hit enter here and type in dates. Now we have a populated list with all the dates. The beginning of each observation page frame. Any questions on how to do that? If you're trying to follow along, or if you have any questions, any troubleshooting, we can hash that out at the end or during the weekend as well. But let me move on to, let's see. Oh, one other cool thing that we can do is for now, let's say we want to print all the dates that ended in 00, for example. For item dates, for every item in that list, I'm going to print. So I want to show you that you can also nest different types of loops inside of each other. For example, we have for loop and then an if statement inside. If I say the last two items, last two digits of this time equals 00. It's going to give me a string, so I should set this as a string. If that's true, print I. We enter. There's only 2 times that started with 00 in this whole list. Now, one more built-in function that you will use a lot is range. For example, for I in range 5, then 5, then 5. What range does is it creates something like a list. It's an item that you can iterate over, and it iterates over from 0 to 5, or from 0 to 4, to 5 items. If you do just range 5, that gives you that weird object type, which is just range from 0 to 5. You can also do list range 5. That gives you a neat list that you can work with. Another function of range is that you can give it more than one argument. For example, if you want your range to be from 5 to 10, it gives you that the numbers from 5 to 9. And then you can also change the steps that it takes. For example, from 5 to 100, and I wanted to go in 5 increments. Okay, so 5, 10, 15, all the way through 25. So now let's jump over to write your first script. And this is where importing and importing comes into play. So let me open up a text editor. So now I can save this. The way you create your first script. Well, let's make a script that does the same function that we wrote for the Fibonacci sequence. Say I want. I'm going to show you how to define a function. For example, let me just jump right into it. The way you define a function is def, and then your function name. In this case, the same as Fibonacci. And parentheses, open and close parentheses. Inside of here, you can choose to have an argument that is required for your function. I'm going to give it one argument, n. And n is going to be the limit of the Fibonacci sequence list. Let's go ahead and save this. Every time that you write a Python script, you want to end it with .py. Save. And the interpreter here nicely colors every item for easier, I guess, readability. So now, one very important thing to make note of when creating a new function is to always document what that function does. The way to do that is just write 3 sets of 3 pairs of quotation marks. Inside of it, just write whatever it does. So an interactive Fibonacci sequence generator up to the limit. And now I want to also let the person who's going to use it know that the arguments it takes are just one, n. And n is has to be an integer. And this is the limit of the Fibonacci sequence. Okay. And you'll see how you can get to this documentation once we import it into our interactive Python. But first, let's give this function its first variables. So a and b, same way as we had before, equals 0 and 1. And while a is less than that limit, n, print, say, a, we're going to end here with a space. What this does here, n equals space, string, that prevents the print function from just doing a list going down of all the items, but instead it does a list sideways. You'll see what I mean in a moment. We can do a to b equals b, comma, a plus b. Now we can give it some user readability, such as let's create a new line and quotation marks, new line, and computation. Thank you for using bit.py. Now, let's say we want to run this as soon as we open it in the shell in our command line. So we can do x equals integer of this is another built-in function input. Whenever we have the function input, the command line is gonna ask you whatever is inside of the quotation marks here. For example, welcome in the line set limit. This here is going to be printed, and whatever you enter after that, it's going to be set as the value of this input. So now it's going to be set, well, x is going to be set as that value, just converting into an integer. So you can go to the line and do print calculating. That should be all. And then at the very end, we're going to run our function. The way we run it is just by calling it. So Fibonacci and then x. Should work if we save it like this. Over here, we can go to ls. There is pip.py. So we can do tell our computer use Python 3 to use Python 3 to run pip.py. Okay, it prints welcome and set limit. So now let's set the limit to say 300. Okay. Prints calculating. It does every item, but it does it even though it's iterating over a while loop. It's printing it on a single line because we set this n equals space. It looks pretty neat. And then n of computation. Thank you for using pip.py. Great. Now let's say we are back in our interactive Python. Say we want to import this module, pip.py. So we do import pip.py. Just there. Once we import it, it's going to be run because that's what the script is meant to do. Be run every time something executes it. So how do we prevent it from being run such that we can just use the Fibonacci function in our interactive Python and not have to be setting a limit and all that? The way we do that is, let me show you something. Very beginning, I'm going to show that name. Actually, just so underscore, double underscore name, double underscore. That's an attribute, an inherent attribute of every Python module or script that you write. This right here is defined as soon as you run it, and name will be equal to. Let me show you over here. I do exit, open a new instance. Now I do import. Oh, I didn't say it. So import code. So now the first line is printing the underscore name. That variable has a value of fib, and that's the name that we gave it. Now it is different if you do, so let's exit here. Let's run fib. If we run it from the command line, the variable name has a value name. So since it has two different values when you run it from command line and you run it from Python script, you can use that to your advantage and have, for example, this if name is equal to name. In this case, if you run it from a command line, run these three lines of code only. And if it's let me remove this for now. And if name is equal to fib, that means you imported it. This is going to be false, and it's not going to be run once you import it to your code. So let me exit out of that. Let's do Let's save this. Go to Python. Import the. All right, main is a string, so we're gonna set it as a string. That's it. Okay, we run it, of course, name is main. What do we want to do? Go to Python 3. Import the. We still have this here, of course, it's printing the name, but now it's not running all of this. And when we do, let's save this, exit, and we run it from the command line. Now it's actually running and asking for a limit in computer. Any questions about name and the difference, the distinction we need to make between running the command line and running as part of another script by importing? No questions so far. The end goal of today's lesson, what time is it? 2:26, is to be able to read the call pipeline. We want to get everybody to understand what each line is doing such that we can contribute to it. I believe the next order of business is to make catalog cross-matching from Richard's last talk 2 weeks ago. And so we should be able to start on that once we finish this. So I want to show one last thing here before jumping into the call pipeline code. Let's see. Let's see 2 and 3. Oh yeah. So one last thing that I want to show is classes. So I want to make a new script, and for this I'm going to use. I'll show you why in a minute. I'm going to use NumPy. NumPy is NP, and import. Let me also use our function, our script. Okay. Great. So let's create a class. A class is an object type that contains functions inside of it. Classes contain functions, which are called methods of a class, and also variables or attributes. And we'll see what I mean in a moment. The way you find a class is just class. And let's create a dog class. Example class dog. And let me save this so it colors it pretty. Yes. Let me turn off my video. Okay. And let's make that k9.py. So, great. So now, by convention, the first function that you should be defining inside of a class is the init function. Inside of it, you notice that I didn't put parentheses here at the class definition, because whatever you put in parentheses inside of the init function it would be the same as putting them here. You'll see also what I mean in a moment. I keep saying that. Self. We're going to define the self variable here. And let's say we want to name our dog every time that we create a new class of dog. So name. So now inside of the init function, let's define the variables that are going to be inherent to every dog class. So the way you do that is self dot and then the name of your variable. Self dot name will be equal to name. And here I could have just used n. This would be n. So it's going to match whatever's in the parentheses to the value here as we're defining it. Self that, let's say the species equals genus lupus. Say self that tricks equals, we can give it some predefined tricks, such as sit from others outside, roll, just a list of the trick that it knows. So that, let's give it a status, what it's doing. So another list, just make it idle or sitting. Say sleeping as well. Great. We can do, okay, so this is a list of statuses. Its status by default, every time that you create a new class, the status will be equal to, so the status is, let's make it be idle at the beginning, so 0. Great. We can do, we can save this. I believe we should be able to run this as it is. Do Python, okay. Import K9. And now we can do, let's say, dog1 equals, we can set a variable equal to a class. So K9 dot dog. And the parentheses, of course, we only need to define n. Self is already defined here. So we just need to give it a name. So noodle. Dog1 is a K9.dog class. And it will do, for example, what's its name? Noodle. Want to check the tricks it knows. By default, it knows sit and roll. And we do b1.status. What's its status? Just idle. Great. So now let's make it learn tricks. What would be learning a trick? Just an item being added to the tricks list. Very simple. So let's say define learn trick. It's a learn trick function. And you want to put self inside of all the functions you define inside of a class. Let's give it an argument, the actual trick they're learning. And let's do self.tricks dot append. We're going to append the trick that you gave it. Go ahead and save that. Fix it so we reload the package. Import K9, D1, then the D1 dot tricks, D1 tricks, and we can also do D1 dot call a method of that class, which is learn trick. We can just give it a trick such as jump. Now we print the list of tricks. Now it knows jump. Questions about that? Comments? Okay, let's one last thing, let's update a status. So sit, for example, we can do self. And for this one, we don't really require any arguments to it. It's going to be the same every time we select it. So self, that status, when I update that status to self that statuses, if that's even the plural of status, 1, which is this item. So we can say this, exit, reload it, import. And also what you can do is give aliases to your packages. So you get K9 as C, D1 dog1 equals c dot dog, and c is going to be equal to k9. Let's say dog, let's name it Bowie. So now d1 dot name has a new name, d1 dot sit. We run that function without any arguments, and d1 status is now sitting. Great. As the last thing, let's import the Fibonacci function into our K9 and implement it somehow. I think we can make our dog learn a Fibonacci sequence. To do that, so I have here already import fit. What I can do is
Very fancy trick to teach you that.
it is right. Python is so it's amazing what you can do with it. Let's see. For example, let's say fib self, and let's give it also a limit.
Make
I
it
wanna run
bark
this.
out the Fibonacci series.
You want it to
One
work?
bark and then 2 barks and so on.
You know what? We'll make it work. Let's make it work. Okay, so list. Okay, so here, yeah, the list of our Fibonacci numbers. Let's make it fib that Fibonacci, which is the function, lim, which is the limit we're going to give it. Just like our function takes one argument n, it's going to be lim. Let's turn this function, instead of just printing, let's make this function save a list, which is what we need. So L equals empty list. We're gonna, instead of printing, L dot pen A. Great. I think that should work. We can save this. Over here, it's going to import the function, well, the module fit. Excuse me. It's going to use the function Fibonacci from the module fit. And then let's say print. Okay, so self that name of the dog, comma, barks. The following. Now let's iterate through the list so that it prints each of the items in a single line. So for item in list, let's say print the item and with a space, and then let's make it bark. So random number equals, and this is a function of the NumPy package, random dot rand int. Let's say a 1 in 10 chance that it's going to bark while saying the Fibonacci sequence. Now, if the random number is equal to, I don't know, 5, 1 in 10, print bark. And equals space, so it's all in the same line. It should work. We can just add at the end a enter, so it's pretty, and save it. Over here, I'm gonna show you something before finishing, and that's import fib. I want to do fib dot, so that's my new function, which is Fibonacci. What I can do is run a built-in function called help, and I can do fib dot Fibonacci. I don't run it. Great. So that takes me to the manual page. And as you can see here, it's printing what I put into 3 sets of quotation marks. So it's an interactive Fibonacci sequence generator, the arguments. So as well, it's important to always document your functions, because people who are using it can just do help and get whatever instructions you give it. Okay. Oh, you can just press Q, exit out of that. Let me reload my Python. Oh. import canine. Say B1 equals canine dot dog Bowie. And then B1 that tricks course, B1 that say fit. And I want you to say fit up to 200. Ooh, non-type object is not variable for I and L. What did I do? Okay, this is a test, everybody. What did I do wrong? It should be giving us a list. Oh, right. Okay, so we want the Fibonacci function to return the value of L, such that when we call it, that's going to be assigned the list. So we can just do return L. Very important. At the end of every function, you want to have return, even if it's not returning an actual value, if it's just computing something such as sit, it's just updating a status. By convention, you should be having return. Won't return anything, but it's good to have it there. In this case, it returns L. We save this, exit, input canine, define the dog, and then say Fibonacci. Boy barks the following. There's a board randomly in the sequence. That's pretty cool. Questions before we move on to the call pipeline? Cool. So let's put all of that into use. We have okay. Next time over, I can show you how to use GitHub. I notice it's getting late, so I'm gonna rush through this. Here we have documentation. Of course, we recognize these 3 quotation marks. Author version, these are arguments of the same module. You can call these to see who made it. Of course, a list of imports that are used. Here, he defines a class pipeline. We notice here the same init function. It's defining the name of pipeline. These are also the, by convention, very first function you should be writing, and function align objects. So let's go through this one, and then you can go through the rest of the functions on your own. For this, align objects. So it's defining self, and it's defining 3 arguments that you need to pass it: object list, output directory, method. Documentation here, of course, align a series of frames to a reference frame. Okay. Now, if the length of the object list that you give it is equal to 0 or is equal to 1, that means if it's just one item or it's empty, insufficient number of images for alignment, it's going to print and it's going to print. That's all it's going to do. Else, if it's more than one item in the list, going to say opening reference frame and opens the first. It tells you it's opening the first item in the list, and defines reference frame. We used fits.open earlier, and it's opening the very first item of the list. Now, it defines the reference data and the reference header as the attributes data and header of the fits file. Then it says converting reference data to fits, and this primary HDU is a function of fits. Just like we saw from documentation, you can go through this, but let's open. Yeah, so you can click on the function, see what it does, whatever arguments it takes. Let's go back to the pipeline. Now we have this reference HDU defined, and we can do writing reference frame to output directory. So it writes the very first item as it is, without modifying it, to the output directory with an A at the beginning, A for align. And then it's going to, what this does here is iterating for every item in the list of objects from 1 to the n. So it already did it for the 0th item. So for item 1, it's going to do, well, if the item is already aligned, say it begins with an A, it's going to skip the aligning on that object. Else, if it's not aligned, it's going to do the same recipe over here. So open the fits file, target frame, target data, find here. And then if the method is astro-align, I think by default it uses astro-align. And method is defined here. You can give it either astro-align or reproject. If you focus on astro-align, it's going to do AA.register. What this does is take the register function of astro-align. So you can also go here to register, go to documentation, and you can see what that function does. Going back to the tutorial, import that, we did that. Register image equals a.register. It takes a source and a target. And now the registered image is going to be a transformed NumPy array, which is very similar to a list. You'll use NumPy arrays as well. Image of source that will match pixel to pixel to target. These two. We go back to the pipeline. It is right here. Target reference for source. And this array is already the target data, but aligned. So what it does is just convert that array, the new array we define, and the header into a fits format, such that it can just be written out to the output directory using A for align in the string. If it exists, it's going to overwrite it. And that's all it does. For reproject, I didn't look too much into this, but it's that primary HDU using the primary HDU function of fits to read it, and then array footprint, just using reproject interpreter, which is a function of reproject. So it's a whole different package, which should do the same process, and then writing it. It does this for the whole list, and that's the very first function in the pipeline. Questions about this function? I know I'm just rushing through it, but we should be at the point where we can research documentation for each of the packages used in this pipeline and understand what it does. And the next step, of course, is writing our own functions so that we can add them to the pipeline. So,
Yeah, I think I'll probably have to go back through this lecture and then try it out for myself. I think that's just how it has to be, right?
I do have a problem, but I think it's just me being stupid. It's just that in my Jupyter notebook is not reading the commands. It's like I'm trying to put like the fits and the darks and the flats, but it's not really getting it. And my Mac, the error says that my Mac doesn't have the permission to do that.
oh,
Yeah,
it might be where you save the files.
okay.
Could be that. We can hash this out one-on-one. But also, if anybody has time, you can stick around. I can show you how to run the pipeline from, from the command line. And with a Mac, you should be able to do it the same way. With Windows, it might be a little bit different, but let me know the problems that you have. Let's see. Let me show you something. Call. Okay, so have you copied the call library to your computer? All this.
Yes.
Okay. Have you set up your config.ini file?
Oh, no. I didn't know about that.
Ooh. Okay. So when I go into this file in your own computer and define these paths. So where you have your darks for, excuse me, for the flats, for the object, the flats, and then your lights.
Oh, okay. I actually did that, but it's not reading like it's giving me an error in this part, in that part. It says that I don't have the permission. That's permission denied.
You might need to sudo. Andy, have you run the reduction pipeline?
The what? Excuse me?
I was asking Andy because I know he also uses Mac. Have you run the reduction pipeline?
So I really wouldn't use IPython Notebook to run it. It's more of like an educational tool. So I would definitely use like the command line and like get Sublime Text or something and write it out in there. So in like a new Sublime Text or a new Python script, you would like import cal, open the files, and then run the functions in this new script.
Okay. So I need to get the suppline with a. Does that has Python in style already or no?
No. So you just get whatever IDE you want to use. I like Sublime Text. You can use whatever.
Okay.
But
like this, I use Atom.
Yeah.
I use PyCharm, and that one's compatible with Mac and with Linux.
Yeah, it doesn't really matter what you use.
But anyway, at the end of code pipeline, you can also modify the pipeline to your own computer needs. But here, I'm gonna touch base on this as well. If main equals main. So once you run it from your command line, it's gonna run all of this, and this is already implementing all the functions defined here to align, to command the dark, flats, reduce. So have you run the actual pipeline from your command line? I think if you do it from the command line from a terminal window, it should work. So here I have defined, say, manual config. I have my own set of darks and flats. Exit. And if I do Python 3 and then the name of the pipeline call.py, it will run all of these scripts below if main equals main. And it should be skip. I know it's writing. It should be skipping because I already have run it before. But yeah, do you want to share your screen? We can hash it out right now, or if you want to do it later today or in the weekend. I'm down to. Oh no. Okay, Victor, Martel, I'll see you around. Thank you for joining.
Can Andy share his screen? Because I know he has a Mac and I kind of want to see what he does.
Alex, you're gonna upload this recording somewhere, right? So people can go back to it. Okay.
It should be in the cloud. I will be downloading and putting it on YouTube. So subscribe, like my channel.
All right.
Cool.
I'm on my iPad right now, but maybe later we could do that. But I mean, it should be exactly the same. So I mean, like all of this, like it's great to know how it all works, but you really just you change the locations and run the cal.py from the command line, and it does all this for you, and it'll give you a clean file at the end of it.
I did have to change about 2 lines of code, but I can show you what those were.
Can you, Alex, can you go to the output directory, please? Oh, so it just puts it right there in the, yeah. So, I mean, it's really just about running it from the command line. It's actually pretty easy to do this, it seems like.
Definitely.
And it stacks them for you too, right? Oh, cool.
Oh yeah. Where is it? Yes.
The very bottom. Nice. That's awesome.
Mm-hmm. Wendy, have you, okay, so you set up the configuration file, and have you tried running this command?
No, I haven't tried it. Do I try it on my terminal?
I would say go ahead and try it. First, you need to cd into whatever you save that code.
Okay. I'm in Jupyter Notebook right now. Is it a good idea if I'm in here or?
Maybe you can share your screen with us, Wendy.
Okay.
So yeah, and again, like I would recommend not, like the Jupyter Notebook is more of a learning tool. You're not really going to run it in Jupyter Notebook.
Truth.
Yeah, usually Jupyter Notebook, if you're using it like a calculator or something like that, then that's great. But for working with things of writing long code, it's just not very useful.
Yeah, especially for testing the new functions.
Yeah, things like that, for sure.
Okay. I don't want to share my screen because then Alex's screen is gonna go away.
Oh, I can. Yeah, no, that's fine.
Okay. I'm in LS. Do I share it?
Yeah.
Okay.
I'm trying to, but it's hold disable attendee screen sharing. I don't know.
I think Alex gets a pop-up that he needs to click on.
Looking for it. Hold on. Participants. Has to start reading. No, that's for the camera, I think.
Okay.
You should be able now.
Okay. Right now I'm in my terminal.
Mm-hmm.
And that's what I did. I just put the LS and it's giving me.
So do you know where the cal.py is saved? And do you know where your data is saved?
It's right here on my desktop.
So you want to CD to your desktop to wherever.
Could you open that file just to see what the contents?
Okay, this is the Richards pipeline. And I have it here, like the data and the reduction subtraction.
Oh, right. So you're running it on the test data. Okay. Okay. Okay, so that's the pipeline tutorials. But do you have the call main pipeline?
The main pipeline?
Mm-hmm.
So you got to go to GitHub and clone the that directory that has the cal.py.
Have you used Git commands before?
You should make the next one of this on how to properly use Git and GitHub.
I do have Git. I actually clone it from there to download it here on a desktop.
Cool.
I don't know how to use it that well. Like I use it all the time, but I use it very rudimentarily. I'm sure one of you guys can teach the more little nuances and whatnot of using Git.
So I clone it again?
So not that one, not pipeline tutorials.
Okay.
You want to go to the list of his repositories and click on the one that's just CAM. C-A-M.
All right. How do I find the repository here?
I haven't used that. Yeah, go to github.com/arcamutu.
Is it the call data astronomical analysis?
Yes.
That's the one.
Okay.
Let's see what you call it.
Do I
Click on the three dots next to wiki.
okay.
Maybe no.
Where is it?
Scroll up. Can you maximize the page? See if it gives you more options, more buttons. Click on code.py.
On what?
Code.py and the list of its items. Yeah. Try would it be copy path? No. So let me open it here.
Do I create a new repository?
No, I would say yes, but no, because it's not letting you give it like the
Like clone it.
the URL. Yeah. Okay, so let me show you my screen. I think we can do it simultaneously.
Okay. Okay, I think I found. Okay. Can you still see my screen?
Yeah.
So yeah, it's that code link. Yeah, there you go.
Yeah. And then I just clone it. Yeah, this is what I got, like permission denied. Let me look that error up.
I would. Can you just download it as a zip?
How do I do that?
Go back to where you were. On the GitHub. No, on the GitHub website.
Oh.
And click back. One more.
Yeah.
And the green button code, click the down, yeah, and just click download zip. And then, so I would go to your documents and make some folder for CTMO or whatever, or if you already have a folder where it's all at, and put it there, and put all your data there too.
Oh. Damn it, what I did.
Just click Command Z. Should undo it.
Okay. Here.
Awesome. Okay, now you want to open up config.ini. You can do right click or what is it, like control?
You just open it as a text file, right?
Yeah.
Oh, okay.
I think if you double click it, it should open like execute it. So try.
Which one? This one?
Config, the second one.
Oh.
So that's the code. Did it open? Try double clicking config again.
This one?
So do control click to config. How do you get the options to like open with a text editor?
You should just right click it and click open with. I mean, at least that's how it is on Mac. Oh yeah. So for you, just click with two fingers on the config.ini.
Choose application.
But don't double click, just click it with two fingers to get like as a right click.
Macs are weird, man.
No, well, how do you right click on things, Wendy? What do you do if you want to right click on something?
Like this?
There you go. Yeah. So open.
Okay, open with.
And then text edit.
Okay.
That one.
Yeah. There you go.
Cool.
And then
now
those
set up your paths.
Oh, okay.
So one thing you can do if you want the exact path is in your terminal, go there, wherever the data is, and you can click print working directory, and it'll give you that whole.
CD into your data first.
Yeah. So click backspace. And so that your data, where is it? It's on your desktop, or where is it?
Yeah, it's in my desktop.
So type CD space desktop. And do you know what that is? It's got to be capital.
Capital thing.
And then you can click tab and it'll finish it, actually, so you don't have to type it all out. So now you're in the desktop, so now you can CD into wherever your data is at.
So it's CD.
Without the bar. Yeah.
Without the
And if you're not,
Mhm.
if you're not sure, do LS, and you'll see it'll print out everything on your desktop. And it's probably going to be a lot, but you can see. So you have it's in this folder called 2020/07/03. At the very top.
Oh, it should be on pipeline practice, no?
Yeah,
I
it should
think
be
I saw it instead of.
Pylon practice.
Okay, so do CD space capital P I and then tab.
Am I? Oh, sorry.
You can just do tab and it should finish up with you.
You can't do spaces.
True.
So click tab before you finish pipeline. So do like a few more letters and then click tab.
Erase everything up to like E.
And press tab. No.
I'm confused.
Just backspace a couple times. Keep going. And press tab.
There.
No, tab.
What's a tab button? I'm sorry.
So,
I'm so dumb.
press. It's cool. Press up. And then tab. Just the tab key.
The tab key?
It's right above
Yes.
caps lock.
I'm sorry. I don't know what you guys saying about.
It should say tab on it.
Press
on
on
your
your view.
on your keyboard, on top of the caps lock, next to the Q.
Enter, you mean?
No,
No, on the left.
the opposite side of the keyboard.
Oh, okay. Yeah. Okay.
There you
Sorry.
go. So that's what spaces look like if you want to do it in the terminal. It's a backslash and a space.
So now hit enter. Now you can do ls to see what's the contents. And now again, CD, and type in pipeline, and then you can hit tab again just to autocomplete it.
Like that?
Mhm.
Oh, sorry.
No, but you have to.
Tap. Yeah.
Perfect. Enter, and then ls again. Should be in data, right? So you can do CD data.
Do I tap?
Not necessary. Tab is only to autofill, autocomplete whatever is missing. So you can just hit enter, then ls again.
Mm-hmm.
Reduction.
For CD.
Correct. CD reduction. If you do ls, it should be your darks, your lights. Oh, wait, not yet.
Oh, okay. I'm getting it now.
You can go to, yeah, you can go to the darks. You have like 30 and 70 seconds. Flat an object. Okay, so at this point, what is the command, Andy, to print the working directory?
So go pwd. So type in pwd and press enter.
Oh, okay.
And then so that's your whole yeah, that's what you're going to copy and paste into this config file.
Mm-hmm.
And it's going to be the dark flat directory,
Okay.
right? I'm pretty sure.
Yes.
Because that was the darks for the flats.
Yes.
And to copy from command line, I think you're gonna have to do like Control Shift C.
Yeah, yeah,
So-
yeah, I know that.
Perfect.
Okay. Yeah, because I'm gonna show you what I was doing. So I will go to, can you guys see it?
Yes.
Yes.
Yeah, I will go to data, reduction, darks, flats, and then go to the file and just get like the information from it, and I'll copy and paste where it was located at. But
Oh, does that
Yeah.
copy it like nicely formatted?
it does, but it gave me an error. Like I wouldn't say like the user it will do it differently.
Okay. So yeah, that's probably the easiest way to do it is to get it the print working directory from the command line.
Okay.
Can you just like copy that and paste it somewhere? I'm just curious what it looks like.
Can I paste it here?
Yeah, sure.
That's how it looks like.
See, yeah, so that's not gonna work.
Okay.
It's not gonna
It needs
fly.
to be like specifically in this format with forward slashes and that kind of thing.
Okay.
And another thing too is I would maybe rename the pipeline practice file just because spaces can sometimes give you issues. So I would maybe make it like an underscore pipeline underscore practice just so you don't have to deal with anything like that.
Okay.
And I would just in general not use spaces in the names of folders just because it causes issues.
Mhm. Would you want to try and run the pipeline today right now, or would you like to do it later? I have time.
Can I do it later?
Yeah, sure.
Okay.
But so that's pretty much the whole process is you just want to do what we just did right here to get your 4 directories
Mm-hmm.
and then copy and paste them into the config file. And then you just run like Python 3 cal.py and that should put all of your align, reduced, and all that into your the folder with the
Lights.
objects. Yeah, with your lights and then also the stack. So once you get all of it running, you literally just like Python cal.py and it'll do it all for you.
Okay. Thank you.
You're welcome. Thank you for joining.
All right.
Cool. Okay, well, I guess that's it. I'm gonna finish the session. We'll talk later.
All right. See you all
Bye.
next week.